Good afternoon. Welcome to another episode of IBM Expert TV Let's Code. Today, we're continuing a series that we started a few weeks back with Jamie Coleman on Open Cloud Native Java on Multicloud. This week, we're going to be focused on AWS, and Jamie's going to walk us through the work that he's done to get a microservice running on AWS. He's going to walk us through everything you need to know to be able to get an Open Liberty microservice application running in that environment. We're pleased to have Jamie do this third episode in our series. If you missed any of the first two, first one was on IBM Cloud, the second was on Azure, and we invite you to go back in the archives of Let's Code and explore those initial episodes. With that, I'm going to turn it over to you, Jamie, to take us through AWS.
Brilliant. Thank you, Neil. So hello, everybody. Good morning, good afternoon, good evening. It's the evening for me. So it's 8 o'clock here in the UK. So this is part 3 of the series. So as Neil mentioned, we started off actually developing the one of the microservices, combining it with another microservice and deploying that to the IBM cloud in part 1. Part 2, we stood up a Kubernetes cluster on Azure and did a very similar thing. And today we're going to be doing the same thing, but on AWS. And then join in a couple of weeks where I will be doing something similar, but I'll be using Kubernetes operators to deploy Jakarta EE and MicroProfile microservices to OpenShift, hopefully on the IBM cloud. Okay, so let's get started. So yes, today we're going to be using the Amazon Web Service AWS Elastic Kubernetes Service, as they call it. So I've been on a bit of a journey here. I've used AWS before. I've never used Azure before I started this series. And of course, I started on the IBM cloud. Now, I've noticed the clouds have got a bit more difficult in regards to just general setup of Kubernetes clusters. On the IBM cloud, you can pretty much 2 clicks and you have a cluster. Azure, probably 5 or 10 clicks and you have a cluster, and then kind of AWS is a different ball game altogether. You can really finely tune your Kubernetes clusters, but it makes it very, very complex, especially for me who's just trying to set up a demo environment. So that's where this program comes in, EKSCTL. And basically what it does, it abstracts away all that really fine-grained level of setting up a Kubernetes cluster on AWS and makes it really simple for a user like me just to get started and get something simple going. So what I've done is I've used this in the background, so you can see my terminal here. The only command that was really required is this, so create cluster. I've added a bit extra to basically just give the cluster a name and say I want 1 node and the type of image I want, because I need a very small image. But I've set this off today before I've started my session, basically because it takes about 25 minutes to set up a cluster. So I didn't want for us to be waiting for that. Okay. So again, just a quick introduction to the technologies we're using today. This is a fully open source stack. So all of this technology is free, even down to the level of Kubernetes, I guess. So Jakarta EE is the first technology. We're going to be using some specifications from Jakarta EE and some from MicroProfile. And what is Jakarta EE? It's essentially an open source community-driven specification for cloud native Java. It's a set of specifications that essentially extends Java SE for enterprise features such as web services and things like that. So these are some of the members. So the strategic members, participant members, and then enterprise members. And without these members, Jakarta wouldn't be where it is. It started off as Java EE, as you may know, and was given to the open source community by Oracle. Okay, so this is the kind of Jakarta EE roadmap. So it kind of came out in 3Q 2019. That's when we first supported Jakarta EE 8. And the great thing about using, say, Open Liberty, which is the runtime we're going to use today, is it has 0 migration. So you can move from an older version of Jakarta EE up to a later version and not have to worry about all your code breaking. So Eclipse MicroProfile is another set of specifications we're going to use today. It's essentially more focused on microservice development. So this kind of came around basically around the time when Java EE was, it wasn't community driven. It wasn't, the releases were very slow, and it wasn't keeping pace with essentially the microservice architecture kind of boom. So a set of individuals and organizations kind of came together to create what is MicroProfile. And these are some of the contributors. And one of the great things about MicroProfile is it's vendor neutral. So you can go to any different vendors and get support from them rather than being stuck with a specific vendor. So this is the MicroProfile 4.1 stack. So MicroProfile shares some of its specifications with Jakarta EE, as you can see on here. So stuff like JAX-RS, CDI, JSONP, and JSONB. And of course, there are standalone projects, and some of these projects work really, really well with the MicroProfile stack. So stuff like reactive streams, reactive messaging, and context propagation, etc. So OpenLiberty is the runtime we're going to be using today. OpenLiberty is an open source runtime, and it came around, say, about 4 years ago. It was one of the biggest open source contributions IBM has done in history. So that with OpenJ9 was over 1 million line or 10 million lines of code, something ridiculous. And it's really built for kind of cloud native development. So it spans all kinds of different types of applications. So from your monolith all the way down to kind of microservices. And for example, it's got things like dev mode. So it focuses on developers. So this allows you to make changes to your code, make changes to your tests, make changes to the server configuration to add extra functionality in without having to keep restarting the runtime. Again, it's kind of focused on developers as well as cloud native. So supports the latest IDEs, the main repositories, the main build tools, and it also supports like we know Jakarta EE MicroProfile, but things like Spring Boot as well. And again, it's great for testing. And people do really love OpenLiberty once they tried it, which is my job to try and get people to try these technologies. OpenJ9 is the JVM we're going to be running on underneath. This is a JVM which really has been kind of fine-tuned for kind of cloud native development. So all the things we need, we want a fast startup time, we want smaller footprint after startup, faster ramp up time in the cloud, and things like that, basically. Cloud native characteristics. So OpenLiberty with OpenJ9 can start up in just over a second, which is pretty impressive. But even if you don't want to use, say, OpenLiberty, even moving to OpenJ9 as your JVM, you will get performance benefits no matter what runtime you're using. So system and inventory. So if you looked at my previous sessions, you will be familiar with these two microservices. Essentially, just to overview again, the system service just returns the properties of a specific host, and the inventory service tracks the number of systems that invokes and stores those properties and information about that in a list, essentially. So we can then recall that list and see all the different systems that are attached, which is cool. So these microservices use a range of different specifications. So we've got JAX-RS, CDI, JSONP, JSONB. We're also using the REST client, config 2.0, and health check. While we're waiting for, say, images to push up to repositories and things like that, I will go through some of the code and just explain it again. Okay, so it's time to get started. Hopefully my Kubernetes cluster is up and running. Yep, it looks like, which is good. So to verify that, let's just get started. kubectl get nodes. Now, hopefully, if everything's come up and everything's working, we should see our nodes come up. I've got my VS Code open in the right directory. So like we did in the previous sessions, we have two directories, a start and a finish directory here. The start directory is basically our starting code. So yeah, what we need to get started. I'm already in that directory, so we're all good there. So the next thing we need to do now we've got our cluster is essentially we need to build our application like we have done previously in different other sessions. So Maven package. So nice and simple. Essentially what this is going to do is compile our source code and put it in WAR files ready for us to put into a image. So the next thing we need to do is we need to do Docker builds. So once this is finished building, we'll do those. So like I said, AWS is it works in a slightly different way. So they don't have like a combined image registry. They have separate image registries for each image, which I found a bit bizarre. I haven't come across that with IBM Cloud or Azure or really anywhere before. So it made playing around with this a bit different. It also meant that essentially when you push up one image, I mean, if you're using a shared registry and you push up a second image that shares the same layers, it will push up the image really quickly. But because it's creating separate registries for each image, the time to push something up to that registry takes quite a long time because it doesn't share the underlying layers, which is a bit annoying. There probably is a better way to do this, but that was what I found from the AWS documentation. Okay, so first Docker build -t, we need system 1.0 snapshot. And we're going to use the Docker file in the system directory. Yeah, that looks all good. So we'll build this. So what this is going to do, again, is just going to, I'll show you very quickly in here. Into system, we have our Docker file. So all it's really doing, it's pulling down the Open Liberty image, the arguments, we're just setting a version, etc. The labels, not required, but good practice. And these are the main things we're doing. So we're basically copying in our configuration for this runtime. We're copying in our actual application, and then we're running this configure.sh script. So if you've watched my previous sessions, essentially what this does is it does an update on all the packages that are inside our Docker image. And the reason for that is to make sure they're at the latest versions to avoid security vulnerabilities and things like that. Now, it only does this while we're building the image. Once we've deployed it, it won't run this configure.sh script. So it's better to spend a little bit more time when you're building your image before you put it in production, just to make sure you've got all the latest packages, etc. So once this is done, we'll go and build the second image, and then I'll quickly take you through the system code just as a refresher of what we're actually deploying today. Just give this a moment. I guess there's a lot of updates in the image that are required. Awesome. Okay, so we'll do the same for inventory. Inventory. And again here. Okay, just make sure that builds, and then I'll quickly walk through the system microservice. So again, the system microservice is what we built in the first session of this series, so feel free to go back and have a quick look at that. Very simple service. Essentially here we're taking advantage of JAX-RS. We're using this application class. Essentially this kind of system application class here puts all the other resources under a common path. So to access our application, it would be, if it was local, for example, localhost, the port, and then it'd be /system/, and then we have our system resource. So the system resource, like I mentioned, all it does is return the system properties of the host. And we're also, so we're using JSONB to do that. So we're returning an actual object, but we're actually returning a response object here, which is the right way to do it. So that way we can say the response was okay, and we can still return the right data. So that's pretty much the whole microservice here, and the configuration is all done in the server XML. And again, very, very simple to do. So let's go check on our build. It should be coming to an end now. So once this is done, the next we'll have to do is essentially log into our container registry, and we have to use that. Basically, there's a few commands you can do. So I'm not going to do this. I've already done it today because it's going to expose all my credentials on the screen. But basically, you want to do AWS ECR get login password like that. So that will return if I ran that my login password. And then again, if we want to get the account ID, it will be AWS STS get we want an output of text and query account. So that will return my ID essentially, and then we need to take both of those and then use that in our Docker login command, and this will essentially point our local Docker daemons or whatever to the AWS registry. So when we push images, it will push them there. So the Docker login command is Docker login. -U is for username, and that is AWS in caps. -P is for password, and that is your password string. So blah, blah, blah. And then you need to basically put HTTPS. So again, this is a little bit more long-winded compared to some of the other clouds I've been using. Then you need your account ID. So put that here. Again, I'm already logged in, so I'm just showing you how to do this. And then .ckr, .evr, and then you need your region. So mine is US East-1, and then you need .amazon AWS.com, and that will then, once you've done all those 3 commands, point your local Docker to log into the Docker registry on AWS. Okay, so next thing we need to do, we need to create a registry. So that hasn't been done for us. So on the IBM Cloud, there is a public registry everyone uses, and that's what I use for my demo there. On Azure, using the Open Liberty offering that's on Azure, creates a registry for me, which I can use. But on here, I need to manually go and do it myself. So it's not too difficult to do. Like I said, I noticed it was a bit different to other clouds because, for example, create registry. You have to create a different repository or registry for each image. And that's what the documentation said. So that's what I followed. But I'll show you how that affects things in a moment. Demo guide. Just call it demo. Call it AWS demo. Just be a bit more descriptive. AWS demo, and then system. So AWS ECR create registry repository name AWS demo system. Yep. So that will go and create me a repository for system microservice. I've definitely done so. AWS. Can we see what I've done here? Let's see. Let me try something else. One moment. Oh, okay. I wrote registry instead of repository. That makes sense. Okay, so I've created one for system, inventory. So we'll do the same for inventory. And that will go and create a registry for each one for me. So I've got both of those now, which is great. So now I need to essentially tag the Docker images, which I built, which has got our application in. So Docker tag, so it was system 1.0 snapshots. And then we want to tag that with the registry URL. So that's for inventory. So they should be the same. Just note these. Yeah, they should be the same. The only difference should be the last word. So system and inventory. So copy that in. And then now we just need to add the tag on the end. So this is where it was a bit different to other clouds at 1.0 snapshots. Yep, okay, that should be all good. So we'll tag that, and then we can push that up. And I'll also do the same for the inventory microservice. Okay, so once we've tagged both of these, now we need to go push them up to our registry. So just use Docker push, and then provide it with the long image name we just created. And hopefully I'm pre-logged in, otherwise I'm going to have to move my terminal and re-log in again. We'll soon find out wherever it says I'm authenticated or not. So yeah, so the problem is here, because I'm creating 2 registries, as you can see, generally once I've done the first push, the second time I do that, the only layer that will be different is the application layer, and possibly the layer where we did the configure.sh. But it means that only those 2 layers need to be pushed up, and they're quite small. They're like 10, 20 meg. Whereas now, when I do another push after this one, we're going to have to wait for it to push all these layers back up again. And that's because they've separated the container registries. Now, I presume there is a way around this, but this is the default way that the documentation said to push images up. So that's what I followed. All right, while this is doing this, I'm going to quickly take you through the inventory application. Okay, so first of all, we have our inventory application. So again, a common path, a resource where we can group all our resources underneath. So accessing this application would be the IP address, the port number, /inventory, / whatever you wanted to call. So after that, we have the inventory resource. So like we did of the properties resource in the system application. And this basically allows us to, it's basically a REST API. So it'd be inventory systems would call this. And then by default, if it's a get method, it would just list all the systems. We're also using CDI here from Jakarta EE. So we're injecting the inventory manager and we're injecting the system client. For this one, when we specify the host name, this will then basically do a GET request to pull the information about that specific host. So then it goes and does some magic to go and get the properties for a specific host. If not, I'll return that host doesn't exist. The only other method, again, we've got the list and we've got reset to basically reset our list if we want to. And the inventory manager, that's where some of this magic's done. So we've got the reset here. Reset here. This is application scopes, so this will stay alive for the life cycle of the application. And again, we just got the ability to add a new system here, and list the system. So I think that's pretty much it. We'll just see where we are with our images. All right. Okay. So the inventory list, again, just listing things. The client, if we go into the system client, this is where it does some of the logic. This basically is what connects to the other microservice. So as you can see in here, we do have two hard-coded values. We've got the system properties and the protocol. Now, we don't have to hard-code that. We could put that in configuration, but generally that wouldn't change. We know the other microservice we're calling. We know it's going to be that endpoint. So it's not so important to externalize that configuration, but you can do if you want to. Just check on this. So also here, now we're actually using MicroProfile config to inject configuration, because the variable here is the port number might change. Port numbers do change, so that we don't want to bake that into our code. So we've used MicroProfile config to essentially inject that. So here we're using the MicroProfile REST client to basically talk to our microservice. So this method creates the client builder, and this is the method that processes the request. So when the request comes back, this processes it and does whatever it needs to, its computation. Just give this a moment. Okay, it's nearly done. I'm going to push up the next image. In the essence of time, because again, like I said, two different registries means it's not going to share any of the layers underneath. System. Just make sure that pushes up before we go back to talk about other things. Cool. Okay. These two microservices, they're quite simple, but they are utilizing quite a few of the different specifications from MicroProfile Jakarta EE, which is cool. It's just kind of to show you how easy it is to build microservices with these. And how easy it is to deploy them to different clouds. Now, the next session is going to be on OpenShift, and you'll start to understand the benefits more of OpenShift by going to deploy these things to different clouds, because then you'll see the different things you have to do specifically for each cloud provider. Whereas OpenShift takes that away. So AWS does actually have an OpenShift offering. Essentially, what that will do is deploy OpenShift in AWS. So you don't have to worry about all these specific things. You don't have to worry about setting up specific Docker registries that are different, say on AWS, are different on Azure, or different than the IBM cloud, because that can all be done via OpenShift. So having this extra layer on top, which basically makes everything the same wherever you deploy it, is very, very useful. And I've come to realize that more and more after going from one cloud to another cloud to another cloud and seeing the different things I have to do to get stuff running on each one. Okay, so only 3 layers left to push up, so hopefully this won't take too long. I've pretty much gone through the whole of the microservices. The next thing we're going to be doing is configuring our Kubernetes file. So let me just open that. So what do we need here? So first of all, we need the system repository URI. So we can find that because we have it right here. Awesome. So let's copy that in. Make sure you put in the right way around. So this one's system. And then same for the inventory. Okay, so there's nothing different in here. That's at least the good thing about Kubernetes. This is exactly the same file that we use for Azure. This is exactly the same file we use for IBM Cloud. So the great thing, at least about this is same. The only difference is the image we're pointing to here. The only thing I should mention, there was a bit of a difference in the Azure Cloud is the registry they create is a secured registry. So you do have to provide some Kubernetes secrets to allow Kubernetes to pull from that registry. Now, we don't have to do that here because AWS has sorted out the security for me. And with the IBM clouds, we used a public registry, so we didn't have to worry about authenticating with it. Okay, so save that. Just go back here. Hopefully this will be done in a moment. I apologize for my slow internet connection. Okay. So yeah, so next thing we're going to do is once these are pushed up, we're going to deploy applications. We're going to check the pods, so they all should come up and running. Then we're basically going to edit one of the security groups, which will allow us to map the ports of our application to the outside world. And then that will allow us from a browser to essentially connect to our application. Again, different clouds require different steps. So this is the way AWS requires you to configure your security. Okay, so we're nearly done. Okay, so we've edited our kube YAML file. Now we just need to deploy it. Awesome. So to deploy it, kubectl, like we've done with the other clouds, apply -f kubernetes.yaml. So that will go and deploy our images. Awesome. So we can check that by doing kubectl get pods. Awesome. So I've noticed, yeah, the pods do come up very quickly. So later on, we do have time. Yeah. So basically, what we're going to do after this is we're going to go and deploy a new microservice. I'm going to show you how you do that with AWS. And what you'll notice will happen is it'll bring up a new microservice. It'll wait for traffic to be readily available for that microservice before taking down the old one. So give this a second. So what we're going to do is we're going to check the security groups. Now I have a very long command here, which I'm going to copy and paste in the essence of time. The only thing we need to do here is, because I called this, oh, I forgot what I called it now. I think it was expert cluster. I can't find out if I scroll up. No, that's not the cluster. What did we call this cluster? I called it demo cluster. There we go. So what this will do is locate the security groups that are essentially associated with our registries. So the one we want to do here is the bottom one. So this is the ID we need. So to edit this security group, you basically you want AWS EC2 authorize security group ingress. Protocol TCP. The port is going to be for the system microservice 3000. Yep, 31,000. The group ID. Group -ID. So this is where we need the security ID. So we're going to take this one. And then we're going to just give it IP range CIDR 0.0.0.0. /0. Right, let me just make sure that makes sense. Authorize security group ingress protocol TCP port 31,000 group ID. That one, yeah. Okay, so that should edit security group now. It would if I spelt things right. You know what? I'm going to copy this command in the essence of time. Okay, so we need our security group, which was this one. Again, this is one of the benefits of using something like OpenShift, because this is something that is a specific thing to authorize this on AWS. So by having something like OpenShift, you avoid having to do this every time. So that should authorize it for port 31,000. Now we need to authorize it for 32,000. I hope I've done the right resource group. We'll find out in a minute if we can access the application or not. So now we need to do kube. First, let's do kubectl get pods just to make sure our applications have come up. There's no point trying to hit them if they have not. Next, next we need to do is to get the external IP address, which will be the host name of our where our application is running. Okay, cool. So everything's running. So kubectl get nodes, and then we need -o wide, so we can provide the external IP. So that's our external IP here. So I'm just going to copy that into a browser tab. 31,000 is the port, and then it was system/properties. There we go. Ta-da! So there's our application. That's running in AWS at the moment. So we configured it. So we've opened the ports up that are required. Now what I'm going to do is quickly show you how to update that application as one final step to go away with. Actually, we'll leave that there. Okay, so if we want to create, for example, we're going to update the system microservice. So let's do a Maven package again. That'll package everything up for us. And then we're going to rebuild the system Docker image. Okay, so Docker build -t system, but this time we're going to do 2.0 rather than 1.0. Snapshot. Oh, if I can spell this evening. System, and then we're going to use the Docker file in the system folder. So that will basically create a new image for us. It'll create it with, well, same image, different tag, and it's copied in a new application code, even though it's the same as what it was before. And again, it's just running the configure.sh script just to make sure all the packages inside are up to date. The next thing we need to do is we're going to need, okay, I'll wait for that to build because it seems like it's messing up my terminal. The next thing we need to do is essentially tag the image with, again, our registry URI. Then we're going to push that up. This time it will be a lot quicker because we're pushing up an image that the registry already has the same image in. So it will share all the underlying layers. So hopefully pushing it up will only take a few seconds. Then essentially what we're going to do is get kubectl to get the deployment to set it to a new image. And then what that'll do is kube will essentially go ahead in the background, spin up a new version of our application or microservice. Once traffic is going to it and it's all okay, it will then essentially shut down the old one. Okay, so we need, what did we need? We needed, we can get that here, Docker images. So we need to do Docker tag. We're tagging the system 2.0 snapshots with 20 minutes ago. That sounds like the right one. With this / 2.0 snapshot. So now we've tagged a new image with the correct URI. Now we're going to push that up. Like I said, we already have a very similar image in the same registry. So this should go quickly, hopefully. Just give it a moment. It probably doesn't help that I set this up in the US. I probably should have set it up in Europe or the UK or somewhere. Latency would be a lot better. And like I said, all the layers already exist. The only two layers that are going to be different is the application layer. And obviously, because we've run configure.sh script again, that layer will be different because updated packages, etc. Okay, so final part here. Before we finish, kubectl, and then we just do set image. Make sure you're in the same directory with your Kubernetes YAML file. So, yep, set image, and then we're going to do deployment / system. So it's basically setting what deployment we want to update. And then basically, so we set kubectl, set image deployment for a system output, and then basically we provide it with the new image. So that will be that, but with 2.0 snapshot. Oh, what's wrong with that? kubectl set image. Oh, right. Okay, that would help. So I need to do system dash container equals da-da, and this will basically make our deployment say, right, you now need to use this new version. So if we do kubectl get pods, we should see one pod terminating. Yep, so one pod came up in 7 seconds. So once you've deployed this once, it's very quick to start up the application. We'll see that in a moment. So we've got our pod name here. Again, we're still waiting for that to terminate. That should be done. So that was how quick we managed to basically spin up another microservice. Now what I'm just going to quickly show you is kubectl. I'm basically just going to prove that we have deployed a new microservice. So pod, and then we just need the pod name. So we'll go to the system one we've done. And we should see the logs for this pod here. It should be very small, very simple. Give it a moment. And we should also, so at 61 seconds, this was scheduled. It started creating the content. So it pretty much came up within 2 seconds. It managed to, from when I hit that that command that basically said use this image, it took 2 seconds to go and pull that new image down, or the new version of it, and actually deploy it and have it actually running. So yeah, very, very quick, very, very fast, which is very, very cool. I think that's pretty much it today. So the main things you need to do, so using these environments are not free, so make sure we shut everything down afterwards. So very simple, kubectl delete -f kubernetes.yaml. So that will shut down all our deployments, etc. The next thing is we need to shut down our registries which created. So it's AWS ECR. Again, a bit more long-winded, shall we say, compared to the other clouds I've been doing so far. Name, I think it was just called demo. Anyway, so these two to shut that down. The last thing you need to do is basically use the EKSCTL command to shut down everything, and it's really easy to do. Don't try doing it via the GUI, because sometimes it leaves stuff left over. I myself have struggled to find what it's actually left over. So, so demo cluster. I think it was demo cluster or expert cluster, and that basically, yeah, just go and shut down try that. And that'll go shut down and do everything for you. So it'll remove all the port forwardings or remove all the things it created. It turns out I just need to figure out what my thing was actually called. But yeah, you get the point. Make sure you shut everything down afterwards. Okay, so we're coming to an end now. Again, this week we've looked at AWS. The first week, if you're interested, we actually built the microservice and deployed it to the IBM cloud. The second session we did Azure, and today we've done AWS. So just a recap of all these technologies, they're all open source, they're all free to use. MicroProfile is built for microservices, and the community is growing and growing. OpenLiberty is built for everything pretty much, with its startup time of 1 second. It's built for cloud native microservices, but you could also run monolithic applications in it if you really wanted to. Jakarta EE, same, it's an open source and it's built for enterprise Java APIs, and the community is huge. And OpenJ9 is the JVM we use today. Again, that is also free and open source, and it's really kind of built for cloud native development. So there's some links to some of the materials here. If you want to get started with some of these things, the OpenLiberty starter or the MicroProfile starter are great places to go. You can basically select what kind of application you want, what kind of functionality you use, and it'll produce some basic source code with the configuration you need for your runtimes, etc. So I just wanted to say thank you. And in 2 weeks' time, we will be looking at OpenShift and the differences compared using OpenShift and Kubernetes operators as opposed to just deploying to general Kubernetes services on the different clouds. So that's it for me. It's my evening, so I need to go get some food at some point. But thank you all for listening. I hope you have enjoyed and learned something today. And stay tuned in a couple of weeks, like I said, where we'll continue this series to talk about different ways we can deploy to the cloud. Thank you, everybody.